Hello, my name is Yusuf and I'm a Formula One software engineer, and I'm going to be showing you today how to program and set up an Arduino Uno and teach you all of the basics that you need to know to get started with your own projects. So first of all, an Arduino Uno is a microcontroller. It's the most popular microcontroller in the Arduino family. Arduino is very popular in microcontroller land because of its ease of use and out of the box packages that come with it that allow you to start working on your project straight away without having to do lots of configurations. So in summary, really, what an Arduino is it's a device that has multiple pins that you can use to interface with the outside world, and that's usually done in one of two ways. Either you connect sensors to those pins and then read them into your software, and then you do some logic with them. For example, if you want to read some temperature measurement, and then if the temperature goes below a certain amount, then you can switch your heating on, which is the second use case for those pins, and that's controlling outputs. So the pins mainly have two uses. You can read information in from sensors, and you can use actuators like motors or coils or LEDs through those pins to control them and switch them on and off. So in this tutorial, I'll show you how to get set up with the software for this um, Arduino family, and this works the same. You'll do the exact same setup if you have any other Arduino board. It's just I'm going to be using this Arduino Uno, which is the most popular board, as I mentioned. So first, let's get started by downloading the Arduino IDE, which is where you will develop your code. So if you just search for Arduino IDE and go to Arduino software, and depending on your operating system, choose which of those applies. So in my case, Windows. Then you hit just download, and then once that's done and you install it as you would any other software, just launch it, and I'll see you back here when you've done that. So now that you have your Arduino IDE all set up, you should have something like this. And at this point, you should connect your Arduino to your PC. And if you're on Windows, it will automatically install a driver for you, and you'll see some pop-ups on the bottom right here. But that's all done automatically, so you don't have to worry about it. The things that you need to do are quite simple to tell the Arduino IDE what Arduino we have connected to it. So first thing, you use the drop-down list and pick the one that says Arduino Uno, and COM10 is the port that it's connected to on your PC, so it's a COM10, connected on COM10. And then if you hit tools at the top there, you want to just double check that the board and port match up, and the programmer, make sure that it's AVR ISP Mark II, so that will allow us to download the software onto our Arduino. And the technical word that we use instead of download software is called flash the software. So when I say flash the software, I mean downloading the software onto the Arduino's flash memory, which is a kind of memory where your software will live. So as a final test before moving on to actually writing code, you want to hit this upload button, which is going to build this code, which at the moment does nothing, but it's going to build this code for us and flash it onto the Arduino. And we just want to make sure that you're able to build and upload the code to your Arduino. So you should see here it says X bytes of flash written. This might be different depending on if you have a different Arduino that you're using for this tutorial. And finally, AVR do done, thank you. So at this point, you're all good to go with the next step. If not, feel free to drop a message in the comments, and I'll do my best to help you resolve your problem. So see you in the next section where we'll actually start writing some software. Now that you have your Arduino IDE all set up to start programming, let's begin with an example of blinking an LED on an Arduino. So the way we do that is by first telling the Arduino that we want to set one of its pins to a output pin that we will use to drive an LED with and blink it on and off. And luckily the Arduino comes with its own built-in LED, so you don't need to make any electrical connections on the outside yourself. Although you could do, and I recommend if you have LEDs and resistors lying around for you to do that. But to keep this simple, what we want to do is start out by saying pin mode, which is a function that we use to tell the Arduino what to set the pin's state to, if we want it to be an input pin or an output pin. So to access the built-in LED, we actually use the LED underscore built-in macro, and what that is, if you hover over it, you can see it says LED built-in 13. So actually, if we go to definition, just for your information, Arduinos come with this file that has many different sort of settings in it that are for depending on the Arduino type that you have and what selection you have here. It will give you the right file, and it will tell you that the built-in LED for this Arduino is on pin 13. So we could just replace this with pin 13 if we wanted to, but it's easier to leave it like this so we can actually see what's happening. Then you want to tell it what mode to use. So in this case, we're gonna say we want this pin to be an output pin. And once again, if you hover over it, you'll just see that output actually just is the number 1. So you could as well just change this to 1 if you wanted to. But I'll keep it like this because it's easy to tell what's happening. So now that we've set the Arduino up to have pin 13 as an output, what we want to do now is switch the LED on. So actually, if we write it down as comments first, so if we switch the LED on, then we want to wait for 1 second. Then we want to switch the LED off. And then we want to wait another second. And then we want to keep doing this forever, and that will basically make our LED blink. So the function you use to switch, actually to control any output pin on and off, you can use digital write, and you give it as a first argument the pin that you want to control, and then you give it what value you want it to be on or off. So you could use 1s and 0s, or you could use high and low, which are the same as 1s and 0s, but I'm going to leave it as 1s and 0s for this example because I think it makes more sense when you're learning. Next, we want to wait 1 second. So there's a built-in function that's called delay that you give it an argument in milliseconds. So 1000 milliseconds is 1 second. So what this function does is it will, when it comes here, it's going to wait at this bit of code for 1 second before it proceeds. So now that we have this bit down, we can actually copy the same thing again at the bottom. The only difference will be that we want to switch the LED off, so we want to change this 1 to a 0. And that's really everything for this example. So to recap, we told the Arduino pin 13 should be an output, which is the pin that's connected to the built-in LED. Then we want to switch it on for 1 second, then we want to switch it off for 1 second, and then keep repeating this cycle. So if you hit Control U or the upload button to build the software and then send it to your Arduino, if we have a look, once it's done, you can see here that this LED blinks on and off every second. And congratulations, that's basically everything there is to know about setting pins on and off. So in the next section, I'll show you how to use something called the serial monitor, which is one of the most useful and powerful debugging tools, and it helps you show you what's going on inside your code under the Arduino. So I'll explain more in the next section. So now moving on to the serial monitor. What the serial monitor is a way for you to be able to print things to a console on your screen while your Arduino code is running, to be able to tell when certain lines of code happen and if certain information has been sent over. So a very useful use case for this is when you're reading something from a sensor and you want to see what those values are. You want to be able to see them on your screen somehow, and this is how you do that. So in this case, we're going to use it to tell us when the LED is come on and when it's come off. So the first thing you need to do to set up the serial communication is type in serial.begin. This is to initialize it. And there's something called the baud rate, which is what you specify, which is the speed at which it communicates. And you just, there's a few standardized baud rate values that you can use, but all this doesn't matter really. Just 9600 is a common one to use. So it should actually be begin. So serial.begin 9600, and then you can start actually printing stuff. So actually if we go here and say serial.println, which is print line, and then between double quotes you can type in something like starting software. So we can do that here. Then at the bottom here we can use that again to say serial.println. So here we can say switching LED on. Then if we copy this line to the bottom here and then say switching LED off, and then we upload the same code. So in terms of the LED blinking on and off, we will still have the same behavior. But what you'd want to do in order to see these messages is on the top right. So if you click serial monitor or Control-Shift-M on your keyboard, you want to make sure that at the top right here you've specified the correct baud rate 9600 as you have in your software in order for you to get the right messages out. So you'll see here it says starting software and it says switching LED on, off, and if you actually make these times longer and then compare it with when the LED is on or off on your Arduino, you'll see that they match up. So this is a very powerful tool that every Arduino developer has to know in order to be able to work on more complex projects. So that's it for this section. The next section will cover inputs, so things from buttons and sensors, and we'll be using an example of a button in the next section. So now we're going to move on to digital inputs and how we can read data from the outside world. So I'm going to be using this Arduino tutorial as inspiration, and I recommend you looking at the Arduino documentation in your own time. There's lots of useful information on there and different tutorials that can help you become better at programming your Arduino. But in this example, we're simply going to look at a button, and the way we're going to define our example is we want it so that when we hit the button, we want to print a message on our serial monitor telling us that we're pressing the button. And when we let go of the button, we want it to stop printing the message. So the way these buttons work, if you haven't used one before, is when you press the button down, this side and that side get connected together. So what this means is if we have one side connected to ground, which is 0 volts, and the other side connected to pin 2, what this means is when we press the button down, the ground will directly be connected through the button into pin 2. So we're going to be reading 0 volts on pin 2 when the button is pressed. However, when it's not pressed, there's no way to be sure what is happening on pin 2. Is it at 5 volts, which is the maximum output voltage of the Arduino Uno pins? Is it 5 volts? Is it 0 volts? Is it something in the middle? Is it floating, as we say, somewhere in the middle where we don't know exactly what it is? So in many tutorials online, people explain this incorrectly and they just set pin 2, and when we get to setting the pin mode in a second, I'll show you pin mode as input. What we actually want is something called input pull-up. So what a pull-up resistor does is it's connected onto the pin that you define it on, so pin 2 for example, and it pulls up the voltage on that pin to 5 volts when we have nothing connected to it. So when the button is not pressed, and this wire is connected to nothing, it's not a complete closed electrical circuit, the pull-up resistor comes in and it pulls up the voltage to 5 volts. So what this means is we know for a fact that when the button isn't pressed, we're going to have 5 volts or a digital high being read on pin 2. And I'll show you actually if you just use input and not input pull-up, how that could break our code. But let's first start off by writing the code for this. And so if we go back to our Arduino IDE, what I'm going to define at the top is btn button as pin 2, and that will just make it easier to say which pin the button is on. So if we define the button pin as input, and like I said, you'll see a few options here, input and input pull-up. We want input pull-up. And let's actually add our serial monitor in. Let's begin it at a baud rate of 9600. And once again, we'll put in a message that says serial.println, let's say starting button software. ... Okay, so what we now want to do in the loop is always read what the state of the pin is, and then we're going to add some logic to print some stuff depending on what the state is. So the function we use is similar to what we used before. So before, for the LED example, we had digital write. For reading stuff in, it's digital read, and all it needs is the pin number. So if we give it button, which is pin 2, you'll see if you hover over this that it outputs a integer. So which is, if you look at the documentation, you'll see it's 0 or 1. So if we type in int button state, what this means is that we're going to get the button state stored each time we go through this loop in this variable button state that we can then use. And if you remember from what we said before, when the button pin is 0 volts or low, that means button is pressed. And we said if the button pin is 5 volts or high, then button is not pressed. And this second statement is true because of the pull-up resistor. So what we want to do here is say if the button state is equal to 0, which means the button is pressed, we want to print serial.println. We want to print button is being pressed. Right. So if we then Control U to flash this onto our Arduino, I have the same connection set up as this on my device, and if we clear the console here, so if I press the button down very briefly, you'll see that it says button is being pressed, button is being pressed, button is being pressed, and as soon as I let go, it starts printing the message. So if I quickly do that again, you'll see it printed some more. And the reason it keeps continuously printing it as I push the button down like I'm doing now is because we're telling it whenever the button is pressed, keep printing this message. So we could add some logic that tells us only when I've just pressed the button for the first time, give me that message once. But that's something that we can do in another tutorial. For the time being, when you just click or press down the button, you're going to get a message come through to you. So in terms of what I mentioned earlier about input pull-up and its importance, so right now if I get rid of this pull-up bit and we actually build the software again and flash it onto the Arduino, and I am not actually pressing anything on my Arduino at the moment, and you can see that it's still saying button is being pressed, button is being pressed, button is being pressed, and that's because the pin is floating, and at the moment it thinks it's reading digital low. It thinks that it is at 0 volts or something close to 0 volts, and that is because we don't have the pull-up resistor that says, when nothing is connected to it, make sure it's pulled up to 5 volts so that we know that we have two well-defined states for when the button is on or off. So if I go back to pull up and reprogram this again, and if we clear the console, serial monitor, you'll see that nothing gets printed unless I actually hit the button. So that is the importance of input pull-up. And there are also things similar to it called input pull down, which are the opposite, but we won't get into that at the moment. This is a good introduction to you on how to use buttons and read digital inputs from the real world into your software. So to wrap up what we did today, I showed you what an Arduino is and basically the two main types of methods or modes you can set any of the pins in, digital in and digital output. And those really are the main building blocks for any Arduino project. So any Arduino project you do in the future will definitely use those two items. They're something that's universal to any, not just Arduino projects, any embedded systems. That's what it's all about. It reads things from the outside world, then processes them itself, and then outputs them in order to take effect or action on the world. So another example or something I wanted to leave you with as a challenge is now that I've showed you how to use digital in and digital out, I want you to create a software that when you press the button down, the LED comes on, and when you let go, the LED comes off. So you should have all the knowledge necessary from what I showed you today to be able to do that. And if you get stuck with anything, let me know in the comments and I'll be happy to help. So as a final thing I wanted to speak about before I let you guys go is this all the different kinds of projects that we can do in the future and what really the realm of possibilities with Arduinos and microcontrollers are. So I just Googled some examples and really you can do all sorts of things like attach LCD and touch screens and program your own games. You could even have things like potentiometers to have something called analog inputs. So today we spoke about digital inputs, which are either 0 or 1. You can have analog inputs, which are things like volume knobs on your car, for example, that read instead of a 0 or a 1, it can read many different values. So 0, 1, 2, 3, 4, 5 volts. And you can use that to increase the resolution of things in your software. One other cool project that we can do is build our own drone. And this is another kind of Arduino called an Arduino Nano, which we can use. We can build our own security system that uses our own pin, or we can even have something that uses a thumbprint or a fingerprint sensor that are quite cheap to buy. We can make some superhero gadgets if we want to and control things wirelessly. We can also do self-balancing robots, which are quite a fun task, and self-driving robots, and it basically automatically detects if stuff is in front of it and moves around it. So yeah, let me know what you guys think, and I look forward to your feedback at the bottom. And if you like, support the channel by subscribing and liking, and hopefully in the near future, more videos will be coming your way. See you all soon.